Thank you very much. For those people who, can you hear me at the back, by the way? Just to double check. We did check before. Good. So those who don't know Alert Logic, let me give you a really brief kind of 360-degree tour of the company. In the UK, it's been operating for about 2 years now. 12 years as a business overall, predominantly known for kind of working and operating with service providers. So if you are familiar with Rackspace, which I'm sure you probably are, Alert Logic has been providing them security services as a partnership for many years, over 10 years I think it is now. This building was a strategic decision obviously from the business to put people in Cardiff because it was a kind of growing area. And clearly, obviously this is our biggest operations in the UK that we have. So the organisation is certainly deeply rooted in Cardiff. We also have a Belfast office where we do a lot of the intelligence side of things as well as the house. Again, another kind of growing kind of tech hub kind of industry area that we're also involved in. So from our point of view, this is definitely a big investment for us. It's a kind of area where we want to see technology and innovation grow. So it's key to us to continue to support these sorts of activities. We've got a great set of experienced people in the business here that also do a lot of speaking and other events. So it's something that we want to continue to kind of grow. We also work quite closely with the universities as well to sort of help them to sort of encourage people into security. So again, it's kind of a big area for us. So what I'm going to talk about today, let me do a quick intro to myself. I'm the EMEA director for the Solutions Architecture team. So essentially I have a team of solutions architects which go around talking to organizations about what we do and how we operate. Some of the key things that we talk to organizations about is how they approach their model to securing cloud infrastructure. So it's a big part of our discussions. Obviously, we provide managed services in that space, so a lot of it's talking about how you can implement security in and around those controls. Some of the other things we do, of course, is a lot of research and threat intelligence-based information gathering. We have about 4,000 clients, and we have good telemetry data. We also consume lots of threat intel data, which we use to service our client base and help them to identify the latest threats. So what I'm going to talk about is I'm going to do some DevSecOps stuff in the beginning. Middle, I'm going to do a quick hack, show you some hacking. Let's hope it works. I'm a bit of a techie, so I like to put myself into danger and have a demo gremlins, but we'll see how that goes. And then afterwards, I'll talk about some remediation. What's the point in me showing you the kind of FUD, the doom and gloom, without kind of giving you some mitigation techniques or approaches? And then again, if you want to talk to us, we'll be here, so come have a chat with us. Team, there's a few Alert Logic staff still kicking around that you can talk to. All right, so first and foremost, DevSecOps. Why? Of course, as you guys are probably aware already, there's this kind of distancing of two different separate, or the approach to bring teams together where they would normally be distant. So previously, of course, there was a breakdown within the business around kind of how they operate. So you have the dev guys operating in one tier, and then, of course, you have the IT ops guys completely doing their own thing, doing something different. And what that's meant is that now when we kind of look at the DevSecOps, its approach has definitely changed. The principles are essentially infrastructure as code, and I'll talk about the reasons why that's kind of important. Continuous deployment, as we know. Automation, monitoring. What I'm going to focus a little bit more on is security today. So we're not going to be doing like this guy, where he's basically just banging loads of buttons with loads of different systems. The view is that we're much more systematic in our approach to security, and we kind of approach it to enable us to secure our infrastructure, even though we're going to be doing lots of continuous deployment, infrastructure code, and kind of fast automation and all that kind of good stuff. So, kind of touched on this. Fundamentally, developers like to build software. So they really change quickly. They want to do stuff really agile. And if you think about a traditional model, so many organizations that I've talked to that are traditionally to the cloud, they've said, it takes me about 6 months today to try and get a bit of kit in a server rack, and it's just too slow. It takes us too long. That's why we love the cloud. And then you've got the ops guys going, well, it's really, we're going to focus on stability and reliability, and how can we confirm that when we move stuff into the cloud, it's going to stay stable and it's going to be reliable and all that kind of stuff. So it's kind of slowing things down. So this kind of mismatch of goals tends to have this kind of conflict typically, and it's a real culture change, in my opinion. If you see a lot of these large organizations, they're kind of saying we want to go there, they're making those approaches of talking about doing the whole DevSecOps and doing digital migration, but ultimately they're going to struggle because their business doesn't have the culture for it necessarily. If you've got sort of early stage adopters, their culture is already in that vein. We don't have enough people for a start, so we need a dev. We need a guy that's also kind of opsy, and he's probably going to want to do something about security. We need him to think about security as well. So pretty much you're going to make that one guy do everything. So they sort of support that, or it's easy for them to support that. So what do we need to consider when we're trying to support this? I'm going to try and talk through this as we go through the hack. Well, kind of after I've done the hack, I'll sort of talk through sort of what we would need to do in order to detect that sort of stuff as a security guy in this industry. But ultimately, when we think about the DevSecOps approach, or the DevOps approach especially, that kind of the ability to have these easy to deploy, a static kind of framework that if I want to go deploy something, I can make sure that it's the same every time I deploy it. Also to ensure that when I expand, it's kind of seamless. We don't want to be slowed down by security. I mean, that's the worst thing, right? Is when a business says, well, we need security, and then somebody says, well, it's going to take us 3 weeks to try and install a SIM platform, and once we get in, we've got to get the agents installed, and oh, by the way, we might have to auto-scale. How do we do all that sort of stuff? So the last thing we want for them to have this kind of agile DevSecOps type of approach, and then realizing that actually all of the stuff that we want to put in there is taking way too long and actually can't handle what we're trying it to do. It doesn't have the agility to be able to handle to do this sort of stuff. Also, how do we ensure coverage? Of course, if we have the ability to set this kind of framework of how we're going to deploy something, and we're going to ensure that we've got everything installed and ready to go, once we hit the go button, how do we ensure that we've got the right coverage? Do we know what we're collecting, why we're collecting it, and how do we ensure that that collection method and the ways in which we connect to these systems is going to be static and supports what we need to do? And then ultimately, there's loads of really cool tools which we find within the cloud platform themselves. How do we integrate with that? How do we make the best of what we've got? And how do we really take the next step in security? You know, one of the things that really excited me, having done security like 15 years, to come in to talk more about cloud, is I realized, well, actually, it's going to make it a hell of a lot faster for me to remediate. I mean, if I was to think about being hacked previously, first thing I've got to do is ring up my forensics guy, and he's got to go to a data center somewhere. He's got to get checked in. He's got to get there, and then he's got to image this thing. Then he's got to try and get the disk out securely, take it to a lab, do all that kind of good stuff. And so it takes us so long to learn anything. Whereas now, what can I do? I can immediately segregate the system, make it safe, bring another machine up so there's no outage potentially. And then from there, he can use that platform to then learn what the attacker's been doing and consume information from it. So we don't want to allow security to slow you down. We want to make sure that it speeds up. So what am I going to talk about? Well, number one attack vector for us, if we look at our client base, is applications. SQL injection is by far the largest amount of attacks that we're seeing. I think our machine learning team, our data scientists, took a chunk of our data set and they said, right, where do we want to focus our machine learning? Where do we want to focus in on what stuff we need to detect, and what would our hypothesis be for detection? So they went, well, okay, what's the biggest chunk of data? The biggest chunk of data is SQL injection. 24% of our data is SQL injection-based attacks. So they're trying to build machine learning capabilities to detect that sort of stuff, followed by things like cross-site scripting, which would be the next. We consume something like 20 petabytes of data a year, so that's quite a significant amount of data. 1.6 petabytes a month is what we're consuming at the moment across log and threat data. And really, it's about consistency when you're thinking about machine learning. It's all about kind of ensuring that you have consistency of data. If you're going to run some form of hypothesis or an algorithm, if you have inconsistencies, it just breaks things down, and the consistency of your threat detection breaks as well. So what we're trying to do, of course, is reduce the amount of noise that hits the SOC, but of course, it benefits the clients because we find more genuine attacks. And as I said, security really needs to be cloud native. Now, when you look at when organizations typically look at applications, they don't think about all the inner workings of it. So when they think about the threat, they're not necessarily thinking about where does the data exist today, who has access to it, and how would they have access to those systems. And sometimes they'll miss things, like if you use a theme or a plugin or something, how often are you actually checking for the latest plugin? How often are you updating that plugin? What's the process of checking and updating those plugins within systems? So for the hack, what I'm going to do is I'm going to use, I know it's easy pickings, but WordPress. So if you were to look on using Google Docs, I don't know if you've come across Google Docs before, but essentially you can go and look for the presence of a number of different things, but ultimately you can go look for people to try and hack. So Google Docs is simply that obviously Google will index a whole load of different sites and links and URLs and stuff. And what attackers have started to do is to use it to search for the right parameters to find all sorts of things, from footholds, like existing web shells that already exist out there that you can just go and find one. But in this case, what we did is we know there's a specific type of plugin called a RevSlider plugin. It's a pretty old version of it that we're doing the exploit on. But there's loads of these still kicking around. I'll show you examples of that. We've got client base where when I was talking about it, I was like, this thing's so old. Like, I couldn't even get it to run on the base image of AWS's Amazon AMI. It just wouldn't work. I installed WordPress, and I was like, right, okay, throw this RevSlider plugin. It just kept erroring all the time, like MySQL doesn't exist, and these MySQL commands don't exist. So I was like, this is stupid. Like, what's the point in showing this as a live hack? There's nobody going to have this. Only to check like a week later with our teams in the SOC to say, we're looking for some interesting stories to talk about. And they said, here's a few, these are really cool. And then one of them was, of course, the exact same RevSlider, and it would happen like a week before. So this stuff still kicks around. Obviously, as you can see, if you do a Google Docs quick search, 173,000 records returned for potential sites that you could go and try and exploit. And I'll explain the exploit a bit later on. So what am I going to show you? I'm sure some of you have come across, or if not most of you have come across the kill chain. The reason why I'm talking about getting good coverage is because if you think about attacking a site, the kill chain kind of follows the rules of exploiting a system. It was actually developed by Lockheed Martin to show kind of more malware-based attacks. So in theory, some of this is kind of redundant. Like, for example, if you do an application-based attack, and you essentially are exploiting SQL injection and you can get direct access to the data, you're kind of exfiltrating the same time you exploit. So there's not really an additional step in the process, but I'll explain it as I go. First thing attackers are going to want to do is to do some form of recon. So in our case, I know this is a RevSlider plugin because I did some searching around and found this as a RevSlider plugin. So that's my target. So I found that, I've identified it. Next thing what I would like to do, of course, is exploit that plugin. So the way in which we do it in this case is that the RevSlider plugin has a means to update. So that's cool, isn't it? We can actually update this thing. If we know it's there, we can update it. The problem is that the update was flawed, so that if you sent the right type of package in the right way, i.e. you just send a request to it and you append the file, it basically goes, oh, there's my update file, and it fails and goes, oh, well, I'll just dump all the contents of that update because it failed because the update doesn't exist in there, and I'll just dump a load of files in there. What you don't realize is that when it dumps those files in it dumps whatever you've left in the directory. So if you're a hacker, what you can do is leave a web shell, which is essentially a tool that allows you to get access to the system and do all sorts of cool things, which I'll show you in a moment. And it's readily available there now, exposed to the internet, that you can just go and make a request to go and get. So I've exploited it now. What next? Sometimes what you might want to do is do some command and control. In this case, it's definitely what I was going to do or would do. I don't really need to do it because I've got a web shell, so I can do anything. I can find database files, I can find password files, I can probably just log straight into the platform. But normally it's good fun because you, as an attacker, you don't want one means to get in, you want several, so that if one breaks for whatever reason, you fat finger something, you lose your connection, you need a way back in. So most of the time you do Netcat. And the interesting thing as well is Netcat, by the way, is automatically on any Amazon AMI. So if you go to a typical Amazon AMI, Netcat's ready there waiting for you, so I don't need to upload anything, I just need to have access to, and I can use the Netcat in my system. So it's there. I tested this out with one of my own instances of Amazon's AMI and Netcat sitting on the system, so pretty easy to utilize. And really, all you need to do with Netcat or in C that's essentially running on the command prompt is just to make a request to a server that sits out on the internet somewhere, and it will just do a reverse shell and you get back access to the box. Pretty easy. Now, if I need to, of course, I can spread. So the next thing would be, where are all my other systems? I might want to put some tools on there and get access to some other systems. Once I have access to those systems, I'll try and get access to the data. So if it doesn't exist on the server I'm on, then I use this as a way to pivot off to attack other systems. And the last step is to exfiltrate. I'm not going to do that in the hack. I'm going to do something else, and I'll show you how that works. Or deface is an option, of course. But ultimately, it leads to me getting full access to the box. Impact, financial loss. Harm, brand reputation, scrutiny from the regulators, all those are kind of typical things you'd expect to see from this sort of stuff, or all of them, of course. If it becomes clear that you've lost a whole lot of credit cards and there's been fraudulent behavior, then chances are people are going to be made aware of it. So now we'll have a quick look at the live hack, if I can make it work. I'll show you how I'm doing this. So essentially, I have a site. There's my WordPress site. I have a hacker machine. Oops. Over here. So this is my hacker machine. So what I've done is I've created a quick shell script. For those who are non-technical, I'll explain this as we go. If I look at the shell script, all it's doing is really simple. there's a command called curl, which is basically like a command line browser, essentially. And it's really hard to see at the back there. But basically what it says is, here's my URL. I want you to take this file, essentially, and run this kind of update plugin function. And it's going to send this zip in. So in actual fact, I could just run this, or I could just take that and just use it in my command line and just run this executable. But I'm just going to do a quick run that. So essentially what it said is upload the file. And now if I want to go and get to that web shell now, because it's extracted that file, and now it's basically got this web shell that's sitting there on the system. So if I want to go and get to it, all I've got to do is go and look at the file, which I have now on that system that I can get access to. So I copy that. Go back to my browser. Up here. That's a bit difficult with mouse. Paste that in. Now, essentially, I've got this web shell that's sitting on my machine, which I didn't have before. Now, what can I do with this? The first thing it allows me to do is just look at files on the system. And you can see where I dropped that web shell. I've got that new.zip, which is basically the file which you append to do the update. And it's basically spewed out this PHP file on the back here. So I'm now in the web shell. I can pretty much do whatever I want now. But in this case, we're going to do something a bit more fun. So I can also go to the console. So I can go and see a few things, like who am I maybe logged in as. So I can do, well, I could use the password first, PWE, I mean, to find out where I am. So I'm actually in this directory. Maybe that's not the directory I want to be in. Maybe we want to go and cat the password file and get the hash files, and I could just go and do that sort of stuff. Or maybe I want to go and upload a file. So what it allows me to do is to go into my upload directory, and I can just basically upload files into that directory. So that's my kind of upload. If I do it ls, oops. Oops, did I upload it? No. Upload that. Back to my console. ls. And now I can see that I've got that d1.html file. And now what I want to do is, if I'm an attacker, I mean, this would be more malicious than in this case, but in some cases we've heard of some stories where rather than doing like full-on ransomware, they just put a file up and then they kind of try and dupe people into thinking they've been compromised, and they'll pay the money anyway. So what we can then do is we can kind of start to move this file. I could do the backup first. So I'm going to move to a directory where I've got my WordPress site. So I've found this. Obviously, probably doing some digging around as an attacker. What I'll do is I'll quickly just back up the index file in case I need it again. And then I can go back to my original directory over here, where the plugin was. Let me check that again. Yeah, so that's my file. And then I'm going to do is remove. Oh, actually, let me go back to that directory again. Go here. Slash all of this noise. D1. HTML to, we'll just do it to here, so I'm just going to call it index.php. And then, what we should see, I've done it right, is the attacker's managed to drop his own files, and he's basically done this whole thing about saying, hey, you know, you've been Bitcoin mining, you need to use some Bitcoin mining, get me some Bitcoins because I've encrypted your disk and you need to give me access to the system. So that's pretty straightforward. I mean, all the guy did was basically just sent a file as he'd expected, and then he could just upload his tools as and when he needs. He's pretty much got the same level of permissions that the website was utilizing, and in some cases it might be as simple as just giving them a quick kind of page, I guess, that gets them to do something, like pay them some money. Or, of course, they would do something more malicious, like actually dump some ransomware on there and get it encrypting disks and stuff. So now what I'm going to do, switch back to the presentation real quick. Are there any questions, by the way? No? Cool, good. Excellent. So that was the life hack. So let's talk through the process. Now, if we think about having kind of this repeatable process in a DevSecOps world and dealing with these sorts of attacks, first and foremost, we need good secure code. I mean, that's kind of where it all starts, right? If you think about the SQL injection attacks, I've been banging on about this for years. We just don't seem to be learning, right? App developers just seem to be failing and continue to fail all the time. So why can't we get the coding right in the first place? That's probably a good place to start, is to start thinking about developing secure code and doing things like code reviews and web application kind of scanning to ensure that you're testing the application before you release. Ensure you've got a secure infrastructure, first and foremost, of course, that's critical. If the attacker can't spread around the environment and he can just reduce the attack surface area and who can access the systems, you can slow him down in a lot of cases. And okay, make the stack more repeatable. I think there's a lot of mistakes made by organizations because rather than kind of taking the approach of having a gold build and following that build through and patching and updating it, the problem they have is that they end up having to start again every time, and they don't have a very good approach to dealing with it as they build out these systems. Of course, once you've kind of got that design, you need to be doing a good lot of testing, and what I'm thinking here is really from a workloads perspective, configuration and vulnerability management is pretty much your number one. I mean, every time you make a change, you need to check, well, what has that change affected? Has it affected the overall deployment of my architecture within the cloud platform? Has it introduced new vulnerabilities? And also when you make that move, many organizations have not said, well, what it looks like today versus what it looks like in the cloud is measurably better than it was before. They've just gone, well, we need to get some quick buck revenue and get some understanding of how this thing operates. So let's just chuck a load of stuff in there, do a lift and shift, and we'll figure it out later, or we'll kind of naturally build that thing in. I mean, that definitely doesn't help your DevOps approach, right? I mean, that slows you down for sure. So they're not doing that kind of initial test of the workloads before they go live on it. And of course, this is pretty can be a process that runs pretty regularly in a lot of organizations now. I mean, they're making changes 2 or 3 times a day, bare minimum, and certainly people have got aspirations to do more. Obviously, monitoring, so user platform interaction, how are we testing, who's interacting with the platform, how are they operating that platform. For server instances, of course, definitely. I mean, if we're going to make changes to that server infrastructure, we want to know those changes exist. We also want to be looking at the network level to understand what are the abnormalities. If we're seeing strange outbound connections, the problem you've got as well is if you've still got that traditional kind of model of disconnect between ops versus dev, you get the dev guys go, oh, I've just gone and built this whole application. It's built on this framework. It's really cool. And the ops guys and the security guys go, all right, cool. What ports do you need open? And they go, I don't know. It's like, well, what framework are you in? Well, this one. It's like, well, what ports is your framework? Well, I don't know. How do I know? It's like, that's your job, isn't it? So then they have to go and figure out what they need. And of course, that breaks things because you end up just not knowing what should be around. So part of it's obviously looking at the network level. And on the apps side of thing, of course, thinking about monitoring the application themselves. If we see some deviation from the norm in an application, then of course, that generally leads to somebody's made a change they shouldn't be doing. Obviously, the frequency of changes now makes it more difficult. Previously, it's quite trivial. You don't change things very often. So when they do change, somebody goes, oh, application just changed. Why did that happen? Whereas now they probably go, well, that's pretty normal. The application's changing every day. So we need to be able to kind of monitor for those changes and actually looking to see if those changes have an impact on our security. Reaction is by far one of the ones which I think a lot of organizations struggle with, in a sense that we're getting to this model where I hated this like a year or two ago when they started saying that you go to InfoSec and some of these security places and security events, and they'd go, oh no, it's all doom and gloom now. Like security doesn't work. You just got to get good at realizing that you're going to be attacked at some stage and that's game over, sort of thing. But there is something to take note of that in essence that if we were able to detect, 205 days, the average before anyone's able to detect a breach, they don't detect it themselves. It's down to some other third party, law enforcement. I don't know, card brands, typically ICO maybe in some cases. So if you think about 205 days, long time before anyone detects anything, and almost all the times I've seen it in forensics investigations, it's always something is a smoking gun. I mean, if you look in the logs, I've seen examples of people that have been hacked for months, and it just says SQL injection attack. I mean, it literally says it in their database of logs, and they're like, yeah, I think you've probably been subjected to some SQL injection. But they just never saw it. They missed it, right? So it's kind of monitoring it is the main, of course, the main thing to see it, but then how do you then react? I mean, if your immediate reaction is, well, yeah, kind of happens, we've seen that before, or the security tool always says that sort of stuff, so how do we know it's real? Then, of course, you're not going to do a good job. And one of the other things I would always say is that if you don't know why you're monitoring it or collecting it, and you don't know what to do with it, don't collect it in the first place, because you're not going to do anything with it anyway. It just becomes noise. So be pragmatic about how you're going to look at this stuff. And if you can react on stuff if you really know why you collected it in the first place and why it's important, because you know why you're collecting it in the first place. After that, of course, blocking it, protecting it, what is that all about? Of course, a lot of people are now saying, actually, it's more about knowing it's happening and then deciding how you remediate rather than looking for active blocking tools. Okay, I buy into that in a big way, but I would also say that think about defense in depth. I still think that defense in depth is critical. Why rely on just one control to ensure that you protect yourself? I mean, you wouldn't do that in your house, right? You wouldn't say, well, I've got windows with locks on it. I'll forget the door. I don't need that because I've got windows with locks on it. It's all about having good, strong defense in depth. So can we block it? How would we block it? Is there controls? Okay, you can use, in AWS, you could use things like knuckles potentially to do blocking. You could maybe do something funky with security groups. Maybe move some systems around in security groups. Move them into a more restrictive security group potentially could help you in a lot of attacks. Ultimately, it's going back down to fixing vulnerabilities. Learn from your mistakes. Learn and redesign your system to fix it. And of course, learn from the app and fix your code. I mean, that's part of what DevSecOps gives you, right? It's the ability to make those immediate changes. I guess in retail right now, you're probably not going to make many changes, but there's an option. So now, how would this look? If you were to just basically consume network traffic, what would this look like? Is my next kind of part to this. So exploiting the vulnerability, what would we see? So the initial attack, we would see this. So in the response of the HTTP headers or HTTP packet, if we were looking at it, we would see, oh, update in progress. That looks a bit suspicious. Maybe we should do something about that. Then you can see, well, actually, it's targeting our RevSlider plugin. And actually, it's going to this particular page. So that's our initial attack. We've seen somebody trying to upload something into our RevSlider. So that should be warning number one. Number two, after they've done that, what's happened? File's been dropped somewhere. Critical location within our www root somewhere. We should be seeing the signs of something's changed. Files suddenly got dropped. In this case, it was a indie.php, which actually, if you go and look at these web shell sites, pretty much most of them are still named that. I mean, it's a clear indicator. They don't change it. The attackers just go, well, who cares? Just put it as it is. I'm not going to rebuild that whole zip file. Why would I? There's a PHP file already in there. So, of course, when you look through the info, you see indie.php, wso.php. You see all the files. I mean, you just got to go look for it. And, of course, when the hacker starts dropping tools in, which he's ultimately going to at some stage, you should see those. You should see those being dropped into your directory. So some of that's about doing file integrity monitoring. Some of it's about looking at log files and detecting stuff through those mechanisms as well. Also, in addition to that, you should start to see some form of command and control, because if this guy's dropping files on, the next thing he's going to do is to try and update his files or get connections to outbound, and you'll start seeing outbound comms. This is obviously the hex version of what's on the right-hand side. So we'd start to see response events that would start to look like this. And if you actually build this thing out, it looks like this, which looks really similar to what I was showing you earlier. So in the case of this case, we're kind of rebuilding some packets from here. So we take that packet capture, we're going to rebuild that stuff. It builds this page, which obviously is essentially that same web shell that I was using to do our demonstration as well. So we should see that in the packets. We should be able to make some decision on that. We should be able to validate it and make clear that, of course, the system has been compromised during that process. So the other thing that I didn't show, but I can certainly show anybody who's interested, Netcat, Swiss Army knife, attackers use it quite often. It's a pretty simple tool. Essentially what it allows you to do is make connections. It also allows you to receive connections if you set it up properly. In this case, my hacker machine has got some data in it, essentially you can see here. And what we've done is basically created the ability to get a remote shell into the system. And then from the attacker's machine over here, or target machine at the top there. If we look at the target machine, it's got some sensitive data in there. If this is my attacker machine, I set that up on my target machine. So it's saying, hey, listen on port 81 and give me a shell. And then back down here, what we can do is then start to connect to that, or be listening on that port, connect to that port, and then from there we can start looking at sensitive data down here. So target system, attacker system, waits for connection, attacker waits for connection comes back outbound to me, and then I get access to. Of course, some of that will rely on port 81 being open on the firewall, but you would do it over 80 rather than going over 81, essentially. And then we should be able to do exploitation of data if we want to. Or the outbound connection could be to reverse the connection back, download files, download tools, and use those tools if you need to. So what next? So cloud features and functions allow you to go really fast. in a bad way. So from an attacker's standpoint, if he gets access to the system and he hacks it, what can he do? Well, in theory, he could start standing up multiple systems to start doing things like Bitcoin mining, potentially. Could delete a whole environment. Code spaces is probably one that everybody's heard about, where they basically just put the company out of business by just going delete and just deleted everything. Could do things like crack passwords at speed. You know, some of the machines that they've got on there now have got really extensive GPU capability, so you could stand up a load of those systems and start doing some password cracking. A few years ago, there was a guy who was talking at Black Hat in Europe, and that was what he was using it for. He was actually building out these massive clusters to crack passwords at speed. And that was years ago. God knows what he's doing on it now. And then also you could use it to attack others. I mean, if you're standing up this environment, I mean, that's most of the reasons why people hack these WordPress sites. Not because they care about the WordPress site themselves, it's because they want volume, they want big botnets they can start to use. They'll start to use them against others. And of course, the APIs that you have on those systems, there's another hack that's pretty simple to do. I mean, if you expose yourself to things like command injection, you typically have, like or you will have with an AWS instance, if you stand it up, it gets attached to a load of metadata. And if you have command injection, that metadata can't be accessed remotely. It can only be accessed from the machine itself. But if you can exploit it with command injection, you could actually directly query the metadata running on the system. You can start to use the metadata and stuff against you. So metadata access can be useful. And for the good, of course, it's like bringing in a hand grenade essentially to a fight against the attackers in a way, because what you can do is you can basically secure yourselves much faster. You know, in theory, we could close that server down and start up a new one, patched and ready to go within a few minutes if we really needed to and we knew what the problem was. Like I said, it can help give us lessons learned really quickly and give us better forensics access. And also native security built in by design. That's, of course, certainly the case if you've thought about going straight in. If you go in lift and shift again, you might find some challenges. Phoenix upgrades, I kind of touched on this as we go. Obviously, there's ways in which what you can do is you can say, I'm going to slowly migrate the platform over. You know, once I update a system, it's ready to go. I might want to slowly migrate systems over to my new infrastructure that I've just built with new patches and new upgrades. You can do things like, of course, fast cutovers and do kind of clustered infrastructure if you want to start rolling these updates out. So it's a much easier way to start pushing updates than we would have traditionally had to do in an on-premise world. Now, didn't build the whole slide, but essentially, Alert Logic builds or consumes a lot of content. And over like the last 60 days, if we were to look at that kind of cross-section of attacks that we're seeing, once we sort of rebuild these things and build out a proof of concepts and build ways in which to detect these sorts of things, what you find is the majority of the data or the information that we're consuming, the threat intelligence data, relates to compromise. So a lot of those kind of new and up-and-coming kind of attacks and kind of vulnerabilities that are being detected relate to compromise. 32% being kind of informational, so it's probably not going to tell you, it's going to tell you a bit about what the attacker is getting up to and maybe some informational stuff. Followed by kind of attack, I think it's compromise plus, which is a weird one that's not formatted there, which is basically exfiltration of data. So it's likely that during this vulnerability, they'll get full access to data. So vulnerability compromise, get access to the direct data, and then of course, general attacks. So lots of content out there that relate to attackers getting access to your data. And that was all I had, basically to cover off really conceptually where you want to go with the DevSecOps stuff, is kind of think about design and concern yourself, I guess, with where potentially attackers are going to get access to your data, working your way back from where that original attack came from, where the sensitive data may exist, and then ensure you've got controls to support it. But of course, they need to be able to grow and scale within your process and procedures within your infrastructure in the cloud. That was it. Any questions? Cool. Well, I'll be kicking around, so if you need anything from me, give me a shout. Thank you.